Good morning. First off, I'd like to thank you for the opportunity to be here and welcome you to the conference. I was unable to make part of the earlier parts of this due to schedules, and we all missed out on the opportunity perhaps to see the launch, but nonetheless, I see badges from all over NASA and all over the country, people that are perhaps in many cases played roles in the activities that Tommy has been talking about and others. Some of you that are hopefully learning something or gathering some of the lessons that have been learned so that we carry all that forward. Now, I was asked to sort of follow up with Tommy and talk a little bit about the era of collaboration and cooperation, or how we learn about what we needed to know in order to build that International Space Station. And I'm going to talk generally around STS-74, and if you look at this crew patch, one of the key things is the bottom of it is the fact that it's our US flag. There's a Canadian flag, which is a lot of people are used to, but there's also a Russian flag. And this mission was specifically oriented or designed to do one thing, which was, in our patch, combine Atlantis with Mir with a docking module, which is built in Khrunichev, the Russian facility, part of the Russian Space Agency, flown to the Kennedy Space Center, integrated into Atlantis, and carried into orbit. This was the first time we'd really assembled a space station, or started that assembly process, where not only were we going to fly up and rendezvous, which had been done, fly up and dock, which had been done on 71, but now we wanted to help build their space station, primarily so that it would make it easier for us to continue to bring shuttles up there. In order to dock on STS-71, they had to move the Crystal module so that it was oriented in a way that was more favorable for the station and protect its solar arrays. And you'll see, I hope, some of the difficulties that had to be overcome in doing that. But before we get there, I want to go over a couple of what I think are historically significant photographs and describe a little bit about how we got there. Because really this is cooperation, this Shuttle-Mir program, as we called it, was about collaboration and cooperation and learning how to do it. So, and I hope this isn't too washed out. This should be a picture that's familiar to most. We've seen it a lot. This looks very ordinary, or very much like what we're always used to, but it isn't quite. Of course, there's the Cape. Another picture further up the coastline with a long lens is actually the picture of New York City here that was fundamentally started the space race, and coincidentally got me involved as a young student in participating in that space race as we adapted. And it's not because of what's going on at New York City that's important. It's because of the platform from which this photograph and the one before were taken. And if we back out with the lens, what we're looking at is, of course, a picture of New York City and the whole economic area of New England taken from a Russian spacecraft, or in some cases a Soviet spacecraft in the beginning. And if we backed out a little bit further, this is a little tougher to see in this room also, but there is New York City, of course, same picture. These are the modules and solar panels of Mir. That's Cape Cod and the coast all the way up to Maine. And if we go down past New Jersey, and the Chesapeake Bay is a little bit obscured, but we can actually make out in better lighting the Outer Banks. So the entire east coast of the United States, or as far north as Boston, was under the gaze, so to speak, of the Soviet Union since the Sputnik. And that got us all started thinking about space program at the time that was going on. Now, to get to where this is where the platform from which those photographs were taken, of course. This is the Russian space station Mir, which base block was launched in 1986, about 3 weeks after the Challenger. So at the time we were perhaps at our worst with the shuttle program, they had just launched the new base block of Mir as a space station after about 7 Salyut space stations had been launching since about 1971. So the Russians had maintained a program of exploration of low Earth orbit and space through Salyut-type space stations since the time, or just after we were successfully landing in 1969 and then on through 1972 on the moon. So they have a lot of history in long duration flight, low Earth orbit, supporting a vehicle. The early Salyuts, of course, were just go up there and it's kind of like Skylab. You're going to go up there and be on board it. Later, the Salyuts Salyut and Almaz, which you don't really hear too much about. It wasn't really a big flyer, but it was, again, a platform up there. Later, they became more complex, and you could have a Progress, a resupply vehicle, as well as a personnel carrier. And then, of course, Mir is a modular vehicle. So the base block is here. It has an axial docking port for Cavant 1 and then for a Progress. And then the radial docking ports hold the other modules, the large science or research modules. And then the Soyuz goes off the nose of the base block. So, and of course, this hardware was carried forward to ISS in a second version. What we're looking at, the target of interest, is on the end of the Crystal module, which is now on a radial port. And the difficulty in docking with that, of course, is that these solar arrays, antennas, and lots of pointy things get in the way. And that's what we had a problem with. For 71, we moved this whole module out to where the Soyuz is, so that when the STS-71 crew docked, they didn't have that interference. But as the program evolved, we realized we were going to fly there more often. We utilized the Russian docking module. But first, to get to this place and really operate there, we had to go here. And this is the statue of Yuri Gagarin at the Yuri Gagarin Cosmonaut Training Center in Star City, or just outside Moscow. So this is their combination of Johnson Space Center, engineering. They do the mission controls from downtown Moscow. Many of you are familiar or have visited there on the era of space station. But believe me, in 1994, this was new stuff. And these are the apartment buildings behind the statue of Yuri, where a lot of the crew, I went over there as the first director of our operations in Moscow, or in Russia. Norm Thagard and Bonnie Dunbar, mission specialists, were there to be trained to fly on the Soyuz. Norm was the first American to fly on the Soyuz vehicle up to Mir. And if you change point of view, viewed from the window of one of those apartments, you can see the Russian complex. All these buildings over here across the forest are the technical area. This is the gymnasium and sports arena. Over here was where the what they call the prophylactorium, but it is where it's where my apartment, where the NASA offices were, and then a lot of the other administrative buildings are not visible. Viewed in the springtime from the window here, it's a very inviting and nice place. It's forest. When we got there in January of 1994, it was looked more like Dr. Zhivago lived there. It was quite different. Of course, it's named after Yuri Gagarin, and Yuri is one of the greatest heroes in Russia, an icon, and the Russian culture honors both Yuri and the other cosmonauts, I would say, much more than the United States looked at astronauts, even more than they look at NFL or NBA players. I mean, this is very serious stuff for them, and part of what we had to learn was the culture of the Russians and the Russian space program, because we were going there to learn, not really to teach. So part of learning is learning how to operate their equipment, getting into what we do at Johnson Space Center and at Huntsville and all the other centers where we train before missions. And we want to train the way we're going to fly, because we will fly the way we train, is the mantra. So here inside the large hall is the Mir mock-up. It's a fixed base, partly integrated with computers for training, and partly a mock-up, sort of like Building 9. But you can get used to procedures. You can verify some of the electronics inside the modules and become accommodated to the various systems that will be operated during a stay on Mir. We also had the Soyuz trainer. This one has both the descent module as well as the orbital module on top. And this allowed the crews to accommodate both for ascent training integrated, entry training integrated, and then some on-orbit procedural training, as you go from the descent module into the orbital module, or you open it up once you're up there. Now, cooperation and collaboration isn't really just about bringing hardware together. It is a lot of tons of hardware coming together from different countries, but the main fact is we got to bring crews together. When it's both crews on orbit, in some cases crews on the ground. Here in Space Cosmonaut training center. And then a lot of engineers and technicians have to come together and understand each other. Remember, they use the metric system. They use the Cyrillic alphabet. They were the Soviet Union. There was a lot of barriers that we had to overcome in learning how to operate effectively. And occasional toasting helped out sometimes. So the docking module was the key, and that was that barrier, that boundary bridge that you saw on the crew patch that was built in Russia for purposes really of flying Buran up there. Modified, they added 2 solar panels so that we could add more electrical power to Mir. It was flown in a transport aircraft to Kennedy, and then Russian engineers and technicians worked with the KSC folks to complete testing, since the vehicle, it was vibe tested and shaken, but it had to be integrated into the orbital payload bay in order to make sure it could fly up there safely and then do its job. This is a picture from the mission. If you were an IMAX camera or carrying one EVA seated at the aft bulkhead of the payload bay looking forward, this is the perspective you'd have. So straight ahead is, let's see, which hand? There's the aft bulkhead of the crew module, the external airlock, and the arm has been used by Chris Hadfield to pick up this docking module out of the berthing, I think you can see V-guides, out of the aft part of the payload bay, turn it, and then stack it on top of an external airlock. That part was before we ever got to Mir. That left now habitable volume all the way up to this reference point, which is where we would contact Mir, and it would look like this if you had not come inside during that particular viewing opportunity. So now we've got the external airlock, the docking module, Crystal, and then let's see, the core block is kind of, in this perspective, aligned with the long axis of the orbiter. So you can see these panels, the solar panels, and some of them have further antennas sticking out of them. And it really was a complex vehicle that we had to ensure that we didn't damage it. We had the right energy to make good contact with the docking system. And then, of course, after our relatively short stay on board, we had to separate, and this time we broke at the interface that we had made first, leaving the docking module. Interestingly, there's one control panel inside the shuttle that operated either of the 2 docking adapters, the androgenous attachment facility. So we had a big switch, because there would have been a lot of points off if we'd separated from the wrong end of that thing. But once we left, you can see that is now the portal for subsequent dockings that have to make the interface here, where you can actually look out the aft payload bay windows and make the docking interface. Whereas with the docking module attached during installation, this is the point of contact, which is really outside of the view of the crew, and you'll see how we adapted to that to manage that shortly. So inside, once we had successfully docked, here's Yuri Gidzenko, the commander of the Russian space station, and me, and we were shaking hands on the inside of the docking module that we had just delivered. You notice how clean and tidy everything is. It's all covered with what we call mouse fur. It's kind of, I don't know, Velcro similar, but it was Russian mouse fur. And compared to Yuri inside the Mir module, where it's distinctly untidy. However, you have to remember that Mir had been up there for about 11 years, and it's like living in your garage, where every 3 months a pickup truck comes and drops off another load of people and stuff, and then takes away, and so pretty soon it gets pretty crowded. We had a mission to not only deliver the docking module, but also to transfer cargo and bring things back. The good news was they knew where everything was. So inside they have cabins where this is Sergei Avdeyev can rest, get the mail, and look out the window. Also a very interesting feature that we pointed out later, that putting windows where the crews sleep and give a view of the outside world is psychologically very helpful, and the Russians recognized that early. Thomas Reiter in the Spectre module with thermoelectric freezers, which they were using to fast freeze urine and blood samples while they were up there for 3 months going through exercise and diet protocols. We were going to meet them at the halfway point of their mission. We arrived, and the first thing we did, of course, was invite them over for a banquet, probably blowing their whole diet protocol right out of the water. But it is a naval tradition that when ships gather in ports, you exchange crews and dine. We brought up one of everything, as well as we had a whole freezer to bring down all their frozen blood and urine specimens. And I was able to convince our NASA management that the freezer would actually be more reliable and operate better if it was full of stuff going uphill, so that it didn't, the little regulatory mechanisms didn't get out of whack or whatever. And so then we volunteered, of course, to fill the freezer with some kind of plain vanilla stuff, what I called thermal regulatory capacitance mass. You just have to know how to work this, Inside Mir, this is the core module. We got together, and this was, in fact, the 50th anniversary of the United Nations. During this mission, we had a video conference with the Secretary General, as well as with dignitaries from both Russia and the United States to mark the occasions and hand over control of the docking module. When we left, you can see that there's Mir, now the docking module, orange, on the end of Crystal, and I think 7 more shuttle flights docked, learned to transfer cargo. People learned, US astronauts learned to operate there for long periods of time. And we began really to trust each other in our operations of flying in space. For us, homecoming was back to Kennedy Space Center, touchdown on runway 33, and then we had the typical crew get-together. It was half the crew. The other half, if you want to call it that, of our crew, the Russian patch part, was still up there, and we would have a reunion some months later because they were halfway through their mission. And here in the main hall in the United Nations, the Secretary General got his, this was a flown item. It was a proclamation and I guess a UN proclamation on the peaceful uses of space and the protection of US astronauts, or of any astronauts actually, so that any international astronauts or cosmonauts or whatever you want to call them who needed some help. I mean, imagine if you were diverted into Atlanta because of a plane change, now you're stuck, you got to get a motel and all the rest of that. Fortunately, you're equipped. If you divert into who knows where in a Soyuz or a shuttle, you don't have a passport, you don't have a MasterCard, I mean, you don't have a cell phone, you're pretty much toast. So without all those key items which you don't carry, you've got to have some help, and the UN had signatory nations to provide cell phones and MasterCards or whatever was needed for astronauts that might need them. Let's see, would you click that? Okay, this is a short, about 9-minute video. I will kind of narrate it, but it kind of puts you in the point of view of the crew as we go through the events that I had just described. There we go. Okay, as I mentioned, you can see now a little more, makes a little more sense what's on the patch. And the launch count, like all of them, starts about 4 days beforehand. The crew is down at the Cape. In this case, we were down here to condition ourselves to the time zone. Remember, Mir operates on Moscow time. That is a significant time change, and if you're familiar with jet lag, after crossing over a few time zones, then think about rocket lag, which crosses half the country in actually every 45 minutes. We wanted to make sure we were prepared for that, so we come to the Cape and live in a room that's lighted when Moscow is lighted and dark when Moscow is dark, so that we are ready. We launched about 7:30 in the morning. You could see me waving air out the window and make sure that they knew I had my gloves on. That's really what it is. And nominal launch, we had a great ride up to Mir with the docking module, did extremely well. And of course, when you're being pushed by 7.5 million pounds of thrust, no matter what's on board, you're definitely going somewhere. We, I think, cover up through the SEP of the solid rocket motors. And then we go through the normal orbital insertion. We do orbital burns. We were flying to rendezvous with a spacecraft that was on 51.6 degrees inclination of orbit, which means from the launch, we only had 5 minutes, plus or minus, around the launch time where we could effectively join them. And that's because of the Earth's rotation gives us about 1,000 miles an hour. Now, the docking module was picked up by the arm, as you saw. We position it precisely using a camera mounted into the window of the external airlock looking at a target, or actually a mirror, on the door of the docking module. That allows us very accurate positioning. We fired thrusters to jam the orbiter up into, we needed the mechanical energy. And then we continued the rendezvous with the guys here. There's Bill MacArthur with the rendezvous software on a laptop. Chris was using a laser, handheld laser. And there is the Crystal module, where our docking module, and this is a view from the camera out on the arm, the elbow camera. Here again, elbow camera. This is the docking module affixed to the orbiter. We're looking, I'm actually flying by looking at these monitors, not by looking out the windows, trying to line up this target with the little 3-wire system. Once we get in position, you'll see again, we fire the thrusters just as the pedals of the docking system overlap each other, and that's to provide an extra boost of mechanical energy so that these mechanical latches can make. It's a little bit like slamming a door or closing a screen door. You need to close it hard enough that the latches are catching, but not so hard that the window and the door breaks. So once we had done it, we'd locked up, then they had to reorient, and you could see we're reorienting the spacecraft, getting power back to the solar arrays. Now, Jim was applauding because that hatch stuck. They couldn't get it open at first. And this has happened before for us too. And I thought to come all this way and then not be able to get the door open isn't going to work. But we did. They were kicking it, and we got it open. Now, they looked happy to see us. Frankly, they'd been up there for 3 months. They'd have been happy to see anybody. But we did bring them mail, packages, food, and lots of things. We also transferred cargo. This is a protein crystal growth experiment. You'll hear more about science on orbit. The scientists considered that it was, their payloads were probably viewed by us the way American Tourister luggage is viewed by those gorillas. They were a little worried about how we'd handle it, and we had to videotape our installing this PCG experiment so that they knew that we had not bounced it off any bulkheads. So we're just about on track. We did bring ice cream up, and there's some actual ice cream eating. This was Bluebell ice cream, by the way. We found out later. Best ice cream in the universe. And that's what they said on Dallas TV. We also brought up a guitar. That's a acoustic. Well, they had one on there that had been in space for 17 years. It was transferred from the Salyut. We brought up an electronic version. Had our going away, talked to the dignitaries, and then really say our goodbyes after really a brief stay, 4 days up there. And then I was the last person out. I'd counted the cameras, because anything that I left up there, they were probably going to make me pay for. And counted noses, because we wanted to make sure Thomas Ryder stayed there, and we had all our guys. And then they'll close the hatch. You'll see the target there on the hatch, which we had used, and there's that little ring sight, as well as this is a standoff cross. There were some springs to push us away initially. We were going down towards the nadir. Orbital mechanics helped pull us away so that we didn't have to fire too many thrusters because we were afraid the outgassing from the thrusters might damage the solar arrays, just the way a big gust of wind might damage the sails on a sailboat. This is shot, of course, from Mir looking out the window. And once we got clear, we got up to about 500 feet. Jim did a fly around, which has been done almost every mission, so that we can do photo surveys of the vehicle. Remember, this has been up there for many, many years. Photo documentation of the spacecraft is very important for understanding real configuration, as well as trying to notice any damage or degradation that might occur. I've got, the rest of this is a little bit of notes on life on orbit that are not unique to this mission, but they are at least unique or interesting. We slept in sleep cabins, or these little closets. I think they're a lot better than just hanging out Velcro to the bulkheads, because it allows you to be, you're not bumped into, so you don't have the light and dark. 2001 was a big influence on a lot of people. They want to run laps in the mid-deck. Chris Hadfield was a Canadian, or is a Canadian. This was his first mission. We figured he must be an ice skater, so we'd spin him up and do physics experiments. Rookies get to do that. And then comes time for the deorbit, burn, and return. There's a whole lot of reconfiguration and preparation going on the day before, where we check out the flight control system. You'll see we're still in kind of routine flight clothes while we use hydraulic power to cycle the elevons, get the GPCs ready to go, check out all the guidance systems. And then we do the deorbit burn and come in our launch and entry suits. And you'll get another view of the plasma. This is the overhead windows, of course, looking overhead and back at the plasma trail, which it's not really, I think it's more like a constant trail. It just flashes back and forth into the window. But it's very dynamic and, to me, unpredictable. Gravity experiments, so we're now getting deceleration. That's really not gravity. It's just we're showing that the orbiter is now decelerating as it gets lower and lower. One thing that's interesting about this mission and about winged vehicles, we came into the reentry at 90 degrees angle of bank, right wing down the whole way, which allowed us to fly 700 miles off track. To get to Kennedy Space Center, we were, from our particular orbit, we had to fly to it rather than just glide or cruise to it. This was not ballistic at all, and that advantage for a winged vehicle is tremendous flexibility. Coming into the Kennedy Space Center, of course, this is a wildlife sanctuary, a bird refuge, and you'll see eagles aren't the only vehicles that fly into Kennedy Space Center. Touchdown runway 33, and this is where you remember that the chief of the astronaut office always says this is a reusable spacecraft, so fly gently. We use a drag chute to help us slow down, of course, and also to help us reduce the loads on the nose gear as it falls through. Because once the nose falls through a certain level, you can't stop it other than the drag from the chute. Now, we called wheeled stop. There's the chute dropping off at usually about 60 knots so that the shroud doesn't bother the main engines. And then, well, we get out of the vehicle here. You could see the spaceport. And then the last slide, if you want to push forward, there we go, gets us to the next step, which is science on board the space station. There were a lot of flights, a lot of learning, and an awful lot of teamwork went in to get us to this. But I like to think we started step by step and built up with our Shuttle-Mir program. That's all, and I guess we'll have questions at the end. Thanks very much.